Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 36 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick this kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. We have a very exciting lesson, and I'm going to show you how to control a servo using your Raspberry Pi Pico W. Sound cool? I hope it does. Had a lot of fun putting the prep work together for this class and hope you guys enjoy it. So in order to do this, what I will need you to do is I will get out of your way and I will need you to get out your kit, and I need you to find the servo. In the kit, the servo is in a little bag and it has a little blue box in it, and that box is labeled SG90. So this has the SG90 servo. So I need you guys to get out your SG90 servo, and then also we need to get 3 wires out. These are the male-to-male wires. Get those out of the kit, and I suggest a red, a black, and an orange because the colors actually mean a little bit in this lesson. Okay, let me come over and let's switch over to the overhead view so you can see live here. We have the Raspberry Pi Pico W all fired up and ready to go. So in this little bag, you're going to get your servo to begin with. Okay, you're going to get your little servo here. And then also, you can see that there's 2 of these little horns, okay? I like the one that has the 4 arms on it, and of the 2 long arms, one arm is a little longer than the other, and makes it a little easier to see where you are pointing. Set this aside. Do not put it on the servo yet. Do not put it on the servo yet. Okay, now what we need to do is hook up this servo to the Raspberry Pi Pico W. You can see that you have a brown, a red, and an orange lead. Okay, brown, red, orange. And most servos have this same color scheme. The thing to remember is brown is ground, brown ground, brown ground, okay? The red is the supply voltage. That makes sense. So now we've got the power and we've got the ground, and then the orange wire is the control wire. The orange wire is the control wire. So I'm going to sit here and I am going to put the orange wire into the socket that has the orange, and then next is the red. So I'll go red to red. And then I did not have a brown wire, so I will use black for ground because usually black is ground. Now we are going to come over here, and what you can see that I've done is I've created a power rail. I've created a power rail from pin 1. Why pin 1? Because pin 1 brings in 5 volts from the USB plug. So you're passing through 5 volts, and the range, the operational range on these little servos is something like 4.8 to 6. And so we want to make sure that we're grabbing this one that should give us around 5 volts. Then the 1, 2, 3, the third over is the ground, and I create a ground rail. So I have a power rail and I have a ground rail. All right, what we're going to use for control, so the red wire provides the power to the little motor in here, but how do we control it? We control it through the orange wire. And so I'm going to connect the orange wire to GPIO 15, which is this upper left one. When I can, I like to use these simple corner GPIO pins so I don't have to do a lot of counting. And so I'm going to come in with the control, the orange, and I'm going to come over here to the corner. All right, now I'm going to come over, and the red is going to go to the power rail. Let me put it over here. The red is going to go to the power rail, and the black, which is ground, is going to go to the ground rail. And now we should be all hooked up at this point. We should be hooked up, and we should be ready to start programming this thing. Now, I should say something here that's very important. I put the red wire into the power rail, and we're getting our power from the Raspberry Pi Pico W. Okay, what you have to understand is this is a very small servo. It draws very little current, so it's completely safe to power it from the Raspberry Pi Pico W. Now, if you decide you want to use a bigger servo, you should not power a bigger servo off of the Raspberry Pi Pico W. Why? Because that servo motor might draw enough power, might draw enough current to either burn out your GPIO pin or burn out your power pin or burn out your entire Raspberry Pi Pico W. So what I like to tell people is it's bad practice to use your single board computer as a power supply. You can have a separate power supply. So if you had a big servo, what would you do? You would take the red wire and you would connect it to an external power supply that can provide the current needs of the larger servo. Okay, and then still you control it over here. So even if you're powering it from a separate power supply, you still control it from the Raspberry Pi Pico W. Now, very important, when you are doing any type of circuit like this, all of your grounds need to be connected together. So the servo ground is connected to the Raspberry Pi Pico W ground. The ground of your external power supply should come in and connect to that ground rail too. All your grounds need to be in common in a circuit, all right? So that's how you would do it externally. I'm not going to demonstrate that because there's too many servos out there, and if you guys want to use a big servo, just use an external power supply, okay? Very good, very good. Now we need to talk about how do we control it? How do we control the position? How do we control the position of the little motor? Well, the motor will go from 0 to 180 degrees, from 0 to 180 degrees, but how do we actually control it? Well, let's see if we can switch over here to our sketch pad, and I'll see if I can kind of come in here and show how this thing works. Okay, let me see if I can get a coordinate axis for us. Give me just a second. And so we're going to come down like this. Okay. And then we're going to come 5, 10, 15, 20, something like this. Okay. And now we will turn that off. And so we have a coordinate axis. Now on the horizontal axis is going to be time, and the vertical axis is going to be voltage. Now this is how these little servos work. The position, the angular position, depends on the width of a pulse that I send to that control pin. Okay, it's looking for the width in time of a pulse. And how does this work? Well, the way it works is if you have, and let me label this time scale. And so this is going to be 5 milliseconds, 10 milliseconds, 15 milliseconds, 20 milliseconds. So this is time in milliseconds, and let's just say this is 5 volts. All right, now if you come in and you give it a pulse of a half a millisecond, 0.5 milliseconds, it is going to go to the angular position 0. Okay, so what I know is that if I have a pulse width of 0.5 milliseconds, it is going to go, let me make sure I did that right. Yeah, 0.5 milliseconds, it's going to go to an angle of 0. If I give it a pulse width of 2.5 milliseconds, it is going to go to 180 degrees. So it's going to go from here over to here. And then it is going to scale linearly from 0 to 180 degrees as you give it a pulse width linearly from 0.5 milliseconds to 2.5 milliseconds. Does that make sense? I hope it does. Now, it is going to look for a pulse every 20 milliseconds. So whatever I do in this first 20 milliseconds, I need to repeat that in the next 20 milliseconds. So if I gave it a half millisecond pulse there, after 20 milliseconds, I need to give it another pulse. So I've got to keep giving it that same pulse to keep it in that position. So 0.5 milliseconds will give you an angle of 0. If we came out to 2.5 milliseconds, let me get it up. I didn't do very good on that. If I come out to 2.5 milliseconds, I am going to get an angle of 180. So now let's think, how would we do that? How would we create these pulses? Do you remember that earlier lesson we did? I don't remember in this class what the lesson number was, but it was using pulse width modulation using PWM. The way we're going to do this is we're going to set up a PWM and we're going to be pulsing a constant width pulse every 20 milliseconds, and then that is going to control the position of the servo. Now, I didn't go out and search the internet to see if there was a library to do this, and sometimes you guys come back and say, oh, I found a library, I don't have to do the math. Well, the whole purpose of this is to try to show you how to think through a problem like this, because even though you might find a library for this problem, you will not always be able to find a library, and if you don't think through things right now on simple problems, you won't be able to think through things when harder problems come along. Okay, so this is our basic points of how this thing is going to work. Now, this is what you have to see. You have to see, like, how does the Raspberry Pi Pico W set a pulse width? I know I want a pulse width of 0.5 milliseconds, okay, but what value would I write in order to get a 0.5 millisecond pulse? Well, the first thing we have to remember is we need to set up our PWM to be at 20 milliseconds. So we want the period here, the period to be equal to 20 milliseconds. Okay, now what frequency, right? We don't set a millisecond value when we set up PWM, we set a frequency. Well, what is frequency? Frequency is 1 over the period. So the frequency that we're going to set is going to be 1 over 20, and then it actually wants it in seconds. So 20 milliseconds would be 20 times 1e to the minus 3, or you could say that it's 1 over 0.02, like that. 1 divided by 0.02 would be equal to a frequency of 50 hertz. So when we set up the PWM, we don't set it at 20 milliseconds because it doesn't want milliseconds. We set it at 50 hertz. 50 hertz gives you a period of 20 milliseconds. So we got to remember that number there. Okay, now how do we actually write, or how do we actually set that pulse width? Well, for the PWM statement, we are going to need to know what is the right value. Okay, the right value is equal to the percentage, how long is this signal up? What percentage of the period is this signal up? And then we multiply that by the total number of bits, which is 65,535. The total number of numbers for a 16-bit number. So you take the percentage that you want the pulse up, the percentage of the period you want the pulse up, and you multiply it by the number 65,535, because that's 2 to the 16 minus 1. That's the kind of range of a 16-bit number. And so how would we figure out what right value we use for our PWM pin to get 0 angles? Well, the right value for a 0 angle would be equal to the percentage, which is going to be 0.5 milliseconds over the period, which is 20 milliseconds. So we're on for 0.5 milliseconds out of 20 milliseconds, and then we multiply that by 65,535, and that is equal to the most wonderful number, 1,638. Okay, rounding it to an integer. Now the right value for 180 would be equal to what? Well, for 180, we want 2.5 milliseconds, so that would be 2.5 milliseconds divided by 20 times 535, and that is going to be equal to 8191. So if I set up a PWM signal with a frequency of 50 hertz and I apply a duty value of 1638, I will be at the 0 position. Similarly, if I set up a duty cycle of 8191, then I'll be at 180. Okay, so let's write these two numbers down. And then let's go over and see if we can start playing around with things on the Raspberry Pi Pico W. Okay, we've got it hooked up here. Let's come over here and let's go to our code view. I have Thonny up and running. And now I don't want to write this as a program because really you don't want to do it just writing these values. We're going to have to get a better algorithm, but let's just see if the way we are thinking about this works. So just down here in the command line, I'm going to say import machine like that. Oops, let's see, maybe, I need to connect here. All right, now I'm connected to the Raspberry Pi Pico W. I'm trying to connect. Let me try again. There we go. Okay, it is up. Now what I want to do down here is I'm just going to write a few commands on the command line and see if this thing is going to work. So we're going to say import machine, okay, and then I'm going to set up my servo. So my servo is going to be machine. I'm going to make this a PWM object, machine.pwm. And then where do I want to set up my PWM? On machine.pin. And what pin are we on? We are on GPIO pin 15. So I'm creating a servo object that is something I can write PWM to. Okay, now I've got to tell it what frequency I want. So servo.frequency, and we said for a 20 millisecond pulse, what we want is a frequency of 50 hertz, like that. Okay, that looks good. Now, what I want to do is I want to do the servo.duty underscore unsigned 16. So this is going to set that right val that we just calculated, and to be at 0 degrees, we wanted to write 1638, like that. Now pay attention to your servo. Let's see, can I see this over here? Okay. I want to pay attention to my servo. Let me get out of your way a little further here. I want to pay attention to my servo and see if it moves or jiggles a little when I enter this command. So let's see. Yeah. Oh, wait a minute. Duty. Ooh, sorry. That was a big, ugly bunch of mistakes, wasn't it? Duty underscore unsigned 16, like that. And let's see if I can bring this up a little. Okay, there, I think you can see it better. So now what we're going to do is, hopefully I didn't lose all my, okay. So now we're going to come here and we're going to get that command again and go, and yeah, it went that time. Now 0 degrees, traditionally is starting at the origin and then you point to the right horizontally, and that is 0 degrees. So now that this is set to 0 degrees, I want to put this little horn on there where the long end is pointing along the x-axis, which is going to be 0 degrees if we follow standard mathematical convention. And so you see the long one, I'm pointing to the right. I'm going to point it exactly to the right, and now that is 0 degrees. That is 0 degrees. Now, if we wanted to take it to 180 degrees, what did we say we needed to go to? We needed to go to 8191. So now I'm going to go here, and I'm going to go 8191, and then I'm going to hold this where you can see it. I'm going to hold it like this, and let's see what happens if we write 8191 like that, and boom, 180 degrees. Okay, 180 degrees. Well, you might think, oh, we'll do half of that. Half of 8,000 would take you to 90, but that's not going to work, right? Because 0 right value was not 0 angle, it was 6131, so you can't just do that. But, you know, if we did it, you'll see it's not going to be exactly 90, but let's just say somewhere around 4,000. Somewhere around 4,000 will be somewhere around 90. Boom. All right, so that is working. So we're controlling the servo. We understand PWM, and this thing is kind of working. But that's not the way we want to do it. The way we want to do it is, I don't want to think in terms of PWM. I don't want to think in terms of duty cycle. I don't want to think in terms of milliseconds, pulse widths. I want to think in terms of angle. And how would we do this so that we can set up an equation that does all the thinking for us, and then all we have to do is think in terms of angle? So let's come back over here and let's think about what we just said. What we just said was, is that if I want an angle of 0, I need to apply what number? I need to apply the number 1638. Okay? If I want an angle of 180 degrees, what value should I write to the PWM pin? I should write 8191. And the angle is going to vary linearly between 0 and 180 as you linearly vary the right value from 1638 to 8191. What do I have here? 2 points. What do I want to draw between the 2 points? A line. In order to get that equation, the equation of that line, what is it that I need to first calculate? The slope of the line. Well, the slope, how do we find slope? Slope, we call it m, and that's equal to y2 minus y1 over x2 minus x1. Okay, what is y2? Y2 is 8191. So I have 8191 minus y1, which is 1638, over x2, which is 180, minus x1, which is 0, and then I get a slope of what? It comes out to 6553 divided by 180. Now, why do I not change this into a decimal number? Because this is more readable to me. If I go back and look at my code, I see, oh yeah, that's the slope. That was that minus that divided by the 180. I can say, yeah, that looks right. That's right. So it's a little easier for me to debug. Now, what is the equation of the line? Well, the point slope formula is y minus y1 is equal to m onto x minus x1. So what do we have? Y minus 1638 is equal to 6553 over 180 times x minus x1 is 0, and so this just becomes x. And now what do we have? We move the 1638 over by adding 1638 to both sides of the equation. So y is equal to 6553 divided by 180, okay, times x plus 1638. Now that's in terms of y and x, but let's write it in terms of the variables that we're using. Our y value was the right value. This is what we want to write to the PWM. The right value, which was our y, the right value is going to be 6553 over 180 times the angle, because our x value was angle, and then plus 1638. So with this equation, what are we able to do? I can pick the angle that I want, and then I calculate the right value that I'm going to send to PWM. Do you guys see that this is, you couldn't see the 1638, but I said it pretty good. So anyway, that wasn't too bad, too badly covered. Okay, so that is our equation. Write that down. Okay, so now with a little math, we should be able to make quick work on the coding side. We should be able to make quick work on the coding side. So let's come back over here, and now let's actually write a program. So what do I want to do? I want to not be quite so tiny. Okay, and this I can make my normal size. And all right, here what I'm going to do is I need to import machine like that. And then my servo pin was what? My servo pin was GPIO pin 15. Now I need to set up my servo object as a PWM object. So servo is equal to machine.bwm of machine.pin. And which pin were we on? Servo pin. Okay, so I am making servo pin a PWM pin, and then I'm calling that object servo. Does that make sense? I hope it does. Now I've got to set the servo frequency, and that was, we said that that was going to be, we just did that, that was going to be 50 hertz, right? We want 20 milliseconds, so we want a frequency of 50 hertz. Now what we're going to do is we are going to set up a while loop. While true, when is true, true, true is always true. We are creating an infinite loop. And now I want to get from the user what angle do they want. So I'm going to say angle, and that is going to be equal to the input of what angle do you desire. I think that sounds a lot better than what angle do you want. Just me. And then this would enter it as a string, and we really want it as an integer, so we make that input an int, like that. Now I've got to calculate my right value, and my right value is going to be equal to 6553 divided by 180 from that equation times the angle that we just input plus 1638, like that. Now I need to send that angle, I need to send that right value to the servo. So I do that by setting the servo.duty underscore 16, and then I want to send it the right val. But now understand, with all this math, this might not come out to be an integer, and this duty underscore 16 wants an integer, so I have to convert that to integer just to make sure that it is an integer, like that. Now I'm going to also come up here and import time, and then here I'm going to say time.sleep is equal to 0.5 for half a second. Now actually I don't have to do this because waiting for user input would be a delay, but I just do this to remind you that you can't just sit there and hammer that servo like in a while loop where you keep writing it, because then it'll jitter. This is a mechanical object. You have to give it time to move. You don't want to move it to a new position before it got to the old position. So I like to put about 20 milliseconds or so delay in there, and so 20 milliseconds would be like 0.02. Not necessary in this point because we're going to get a long delay in here when we're waiting for the user to put the new number in. Okay, this is very exciting. Let's see what happens. Let's come back over here and let's see if I had a view. Let's see. Was this the one that showed them both? Was this the one that showed them both? I thought I could. Didn't I just show you both the, let's see. Yeah, what happened? Let's see. I do not know how I lost that shot, but let's just watch it and I'll tell you what value that I'm going to have, okay? And so what I'm going to do is I'm going to come back over here and then I'm going to run the program just to see if it will run. What is that line 2? Oh, import. Import. All right, now let's run it. Servo pin is not defined. Servo pin. Servo pin. What on earth did I do wrong? Servo pin. What line is that in line 4? Servo is equal to machine.pwm machine.pin. Uppercase S, lowercase s. That looks so right when I was trying to look at that. All right, come in. What angle do you desire? Well, I'm going to put a 0, and then I'll come back over here where you can see it. Now, what do we expect when I put in a 0? We expect this to point exactly to the right. And so I'm going to go like this. Why did that not do anything? What did I do wrong here? Sorry. Come back over here. Hopefully you guys saw this. It should be a U, unsigned 16-bit like that. So now we're going to run it. We're going to tell it we want a 0. And we're going to come over here. Holding this thing, I'm having to work with my left hand, so this is no fun. All right, so we're going to go like that. Now what do we expect? We expect it to go over to the right. When I click enter, type in 0. Hold on. Okay, what angle do you desire? I'm going to put in a 0. Boom. Okay, it went straight to the right. This time I'm going to say I want 90. Boom, straight up. This time I'm going to say 180. Boom, straight to the left. 135, which is 45 to the left of 90. I can put in 45. I can put in 20. And this thing goes wherever I want it to go. So how neat is that? So with just a little bit of math, we have been able to write a program that allows us to select the angle that we want the servo to go, and then it will go to that angle. Now, there's a couple other things I should have said about the servo, and that is something that always bugged me when I was teaching students. And what students do is they like to fidget, so they like to get this and spin it from the horn. Do not spin a servo from the horn or from the output drive gear. Why? The servo is not a fidget toy. There are many good fidget toys out there. Don't try to use your servo as a fidget toy because it's very easy to strip those little gears that are in there. And if you are playing with trying to drive this from the output, you'll strip those gears and your servo will be ruined. And students used to sit in my class and go like this with their servo, and it would really it would really drive me crazy. So what did you learn today? Your servo is not a fidget toy. Leave a comment down below. My servo is not my fidget toy. Okay, so that's one thing that you need to learn. All right, so this has been a pretty slick lesson if you ask me. Now, what your homework assignment is for next week, I want you to add to this circuit, I want you to add a potentiometer, and if your potentiometer is always all the way to the left, I want your servo to be at 180 degrees. Why? Because 180 is over there to the left. And so if your potentiometer is turned all the way to the left, the servo is at 180. If your potentiometer is all the way to the right, then the servo is like this at the 0 degree position. And then I want you to be able to control the position of the servo using the potentiometer. Sound pretty neat? I hope it does. Guys, I hope you're having as much fun taking these lessons as I am making them. I want to give a shout out to you guys who are helping me out over at Patreon. YouTube isn't showing me a lot of love these days, and you guys that are helping me out on Patreon are the guys that are keeping this channel going and keeping these videos coming. So I appreciate what you guys are doing. If you enjoyed the video, give us a thumbs up. If you haven't already, subscribe to the channel. When you do, make sure that you ring that bell. And as always, share this video with others, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.